change. So, okay. So first let's find domain, right? And if you look, that goes, that's from the denominator. Wherever the denominator is 0 is excluded from the domain. So another way to say it is x shouldn't be equal to 2, which means the domain in interval notation is negative infinity to 2 and 2 to infinity. Okay, so you have to take the whole denominator regardless, right? And so now that I've done that, let me factor the numerator here. And when I do that, I'm going to get x minus 4, x plus 3 over 2, x minus 2 squared. And you see that nothing cancels, no terms with variables cancel from the denominator. So my vertical asymptotes, there's just one, it's x equals 2. Okay, and let me just put that here so I kind of have an idea what's happening. All right, horizontal asymptote then. I always like to go back to the original function, just because they might be a little bit more clear. So here I have an x squared, but look at the denominator. I have an x squared. Remember, that's how we looked at like leading terms before as well. So x squared over x squared, same terms, same exponents. That means it's going to be y equals 1 over 2, right? Because this 2 is going to be a coefficient when I multiply out that denominator of the leading term. Okay, so that's my horizontal asymptote here. 1/2. Okay.
Wait, how did you get a half? Sorry, couldn't again.
Say that again?
How did you get a half for the?
I got a half because okay, so I saw that the exponents were the same top and bottom of the leading terms. And then had I multiplied all this out, I would have gotten in the bottom 2x squared plus blah, blah, blah. So then if I take the highest exponent there and the term with the highest exponent here, the coefficients will be 1 over 2. Other questions? Okay. And remember, to graph, I also said it was good to find the zeros. Let's find the zeros. To find the zeros, right, it's f of x equal to 0, right? Behind the scenes, it's f of x equal to 0, which means you don't have to show all this, but when I set the entire function equal to 0 and you cross multiply, all that remains is the numerator equal to 0. That's why you could just skip all of that and just set the numerator equal to 0 and say the zeros are at 4 and negative 3. So that's at 4 and negative 3. Now, the book is also asking you to find y-intercepts, right? Y-intercept is f of 0. So it's, kind of the reverse of what we did before, f of 0. That's when you plug 0 into all of your x's. So if I go into the original function here, in the numerator, I will have 0 minus 0 minus 12 over 2 times negative 2 squared, right? So that's negative 12 over 2 times 4. Okay, how much is that? 12 over 8. What do you guys think? 3 over 2?
Yeah.
Okay, so that's how you find the y-intercept, and that's right there. Okay, any questions so far? All righty. So look, now I can graph just like I was before. And finding the y-intercept actually kind of helps me out because it does give me that additional test point, okay? So look, I have one vertical asymptote. To the left of it, you see that the graph crosses the x-axis at -3, and then it has to cross the y-axis at -3/2. And if you have to follow the horizontal asymptote and the vertical asymptote, then really that's how it's going to look. All right, let me just fix it. Are we okay with that? You guys are either frozen. I think you guys are frozen, but I'm gonna assume you guys are okay with that. Okay. If there are any questions, tell me. You can chat them to me as well. Okay, now plot twist. I didn't, say this last time because I didn't want to throw too many wrenches in there. You remember how I said when it exits off the screen on the bottom, it re-enters on the top? Remember when I said that? Okay, what's a rule if, without exceptions, right? So here we go. Where did this asymptote come from, the x minus 2 asymptote? It came from here, right? And what's the multiplicity of that term? Our favorite
2.
word, multiplicity, 2. That's an even multiplicity, right? Because it's an even multiplicity, when it goes off the screen on the bottom, it re-enters on the same side. Plot twist. Okay? And so then it would come up here, past the 0, and then follow the horizontal asymptote. So that